just drop the data. We have to like send it, so it has to go somewhere. So the default route is like, if it doesn't match, it's gonna go there, like whatever IP,
Like in the real world, like what would the default address use that packet for now? Since like say you send it to an IP address, but you can't find it, so it just goes to default.
It's like because the router, like it has like a default thing. Like the router has like a safety measure, like hey, if it doesn't like match it, like it's gonna always go there. So that's like the default thing. So that's how like the router works. So like you always need a safety measure. It's there, like their safety measure. Like, it's gonna always go there. So you can like set it to your computer, like hey, this is my default route, so it's gonna always go there. So.
Oh, okay.
Okay. So it's like a fail-safe thing. So.
Yes.
What's your name? Chris. Chris, yes, you were the one that did all of the stuff on the different protocols or the different methods of congestion handling. In terms of real-world applications, could you give me an example of what, since those were sort of just sterile, like just here's a graph with some stuff, like what's a real-world application of like load shedding versus, I forget what some of the other ones were, load shedding versus one of those other ones versus another one. Like a real world example of how those would be implemented. Not necessarily implemented, but in a real world case where this one would be used versus another one.
Okay. Could you go back to the presentation?
I don't remember what name.
Let me bring up this slide right here. So this, so in this graph up here, I don't know if you can see that real well. Can I zoom in? Yeah. So it goes from slower to faster in that, I guess, graph. And slower algorithms, they're more preventative. So it tries to stop congestion before it happens. While something like load shedding, which I said was like heavy artillery, that's where congestion is so bad something needs to happen like right now, which is, it'd be faster and it's more reactive because congestion is already happening. And so like provisioning to load shedding, it goes from slower to faster. The other ones are all in between. Each one has like their own niche area. Did I answer your question?
Yeah.
Okay. Yes.
Which group about this? Is this kind of how you prevent a DDoS attack? So you would just like shed it all pretty much, all the requests?
Probably the shedding with a DDoS attack is because there's legitimate pings to the server. So you can't just like shed everything. This chapter didn't really talk about DDoS prevention, but
and basically, actually, we can't prevent DDoS attack. But one way is preventing DDoS attack is like we can just like bound the IP addresses. But like we have like thousands of like zombie computers, right? And it just sends the ping to our server. We can't actually bound like those 1,000 IP addresses separately. That's why it's like really complicated to prevent DDoS attack. That's why like organizations really afraid of like DDoS attacks. Did I answer your question?
Thank you.
Which group was that?
So, these 5 different approaches, are they like in a real world environment, like router? Are they using just one specific? Is the router using one specific algorithm for this? Or are they combining the two, like all these, into sort of like a hybrid approach to kind of like create the most optimal, like I guess output, I guess.
so companies would, or like ISPs would use like all of them at once, and depending on how bad the congestion is, it goes from preventative, from like network provisioning, then if it gets a little bit worse, it starts rerouting the traffic, which is traffic aware routing. Then if it's still, congestion still gets bad, they would use admission control nets, which like you just can't use this route or go somewhere else.
Another question I have is that like a cause of conflict? Is that like a cause overhead for all of those running at the same time if you're combining them all together? Or like how does it handle, does one run at one time and then the other stop and then the next one starts going, or what?
I don't know the technical details of it, but I assume that's all handled like within the router. Like Cisco would make their own little thing inside of their routers, and like Linksys would use their own type of system. But I'm sorry, I don't know the technical details of all of that.
Maybe it could be just like we have different kind of like routing algorithms, right? Hybrid algorithm, or like just like dynamic algorithm and static algorithm. For example, about like admission control, it's just like whenever admission control used for like object-oriented or like connection-oriented networks, right? So when we have connection-oriented networks, we have virtual circuits. So and we have now congestions. But admission control works. Okay, we have conjunctions. We cannot create any more virtual circuits, and it's like that. I think like it depends on like what kind of networking we use, and also like routing algorithm we use. Depends on that. We can use one of them.
So it's really just a matter of like what situation you're in that depends on these 5 different sort of things.
Yes,
Right.
could be just like is it using like a state link network, or is it using like more about like algorithm, or is it like more about distance vector algorithm? Based on that, we can just choose some of them.
Okay. Thank you.
Any other questions? Yes.
About the sharing the network that happens between computers that are connected. From the program that I've seen, like you entered an IP and it will see if it's within the network, right? So within the first place, like how does it know that this IP is within the network? Like is there like a specific sequence within the IP or?
Like when there's like a device on the router, like they have like a table. It's like a mini database. Like the router has like a routing table, so it stores the the values of the devices and converts to the binary, whatever. Like there's like a lot of things. So router just that it just matches all the information it has like in its database. So that's what it is, and kind of like gets matches it in a sense. So.
Yeah, we will do this in the exercise after the class. I mean, in the second half of the class. The router has a routing table which shows which networks it is connected to. It might be more than one network, and it's going to check in its table which interface I should forward this packet to. So it's going to take the first part of the address and match it to all the entries in its table. If it matches one of them, it forwards it to that interface. If it doesn't match, forwards it to default router. So this is what their program has done.
So there's a specific sequence for the.
Yes, for each network that the router is a part of. We're gonna see that in the second half of the class.
There's like a map to like it does like an AND operation, so it just compares the AND operation like key to the values in the routing table, and then like it understand yes it's gonna go there. If not, it's gonna go to default route. So it's like an if-else thing. So.
Okay, go ahead.
Does the type of the network, like wired or wireless, matter when you deal with congestion of traffic?
Can you repeat that?
So the type of network, whether it's wired or wireless, does that matter when you deal with traffic congestion? The protocols for managing congestion are differently, or?
Yeah, with like Ethernet, that's wired. So wired connections naturally have like higher packet size, and wireless would naturally have lower packet size because it's less reliable and all that. So with congestion control, I guess it really depends on like if it's coming from a wired to a wireless. That's when like the algorithm to determine which algorithm to use will come into play if congestion starts happening. Because then if like it's going from Ethernet to wireless, it would have to break up the packets to fragments and then go from there. Did all the groups ask a question? Okay, thank you.
Okay. That's the project presented.